Halfway there. Today we're going to talk about Chapter 10, Acids and Bases in Equilibrium. So this is going to be building on everything that we've been working on so far and putting them together. So clinical lab techs, they prepare specimens for the detection of cancerous tumors, types of blood samples for transfusions, and a whole bunch of other things. They're also going to be able to interpret and analyze the test results, which are then passed on to the physician and then on to the patient. So knowing and understanding these are going to be very important in your medical career. So the term acid comes from the Latin word acidus, which means sour. And if you take like lemon juice, which you know is an acid, you put it on your tongue, it is very sour. So that's a way that you can remember that. And so, yeah, the sour taste of vinegar, lemons, and other common acids in our food. Citrus fruits and fruits are sour because they contain the acids. So today we're going to describe it and name acids and bases, identify the Bronsted-Lowry acids and bases, and build on everything that we have been working on thus far. So with acids, there's a subcategory, which is aromatase acids, and these produce hydrogen ions when they dissolve in water. So you can see here a very common acid that we use in the lab is hydrochloric acid, which is known as HCl. And then when they have a liquid react with it, water, it's going to separate it and form it into hydrogens and chlorines, okay? They're also electrolytes because they provide those H pluses in the water. They have a sour taste, they turn the blue litmus paper red, and they can corrode some metals. So how do we name these? Well, the acids with a hydrogen ion and a nonmetal, or a CN ion, are named for the prefix hydro, and they end with an ic acid. For an example, what we were just talking about, hydrochloric acid. So that's the hydro starting, the chlor for the chlorine, and then the ic for the acid. So acids with a hydrogen ion and a polyatomic ion, they're named by changing the end of the name of the polyatomic ion from ate to ic acid, or ite to os acid. So here's chlorate, because it has the CO3 minus, and then when we have the ClO2 minus, that's chlorite, okay? And chloric and chlorous acid, so you can see. A handy dandy little table so that we can refer back to it as we go through these, okay? So let's do a study check, your favorite. So select the correct name for each of the following acids. So pause me and come back. So for this one, it would be hydrobromide, right? So that would combine together to make hydrobromic acid. So the name of an acid with the hydrogen ion, right, at the beginning, and the nonmetal uses, bromide, uses again the hydro and the ic. So that's how we get hydrobromic acid. For this guy, we're going to get carbonic acid, because CO3 is carbonate, and then there's a H, right? So the acid with the hydrogen ion and the polyatomic ion ending with 8 is an ic acid, okay? And then this guy here would be bromous acid, because again, an acid with a hydrogen ion and a polyatomic ion ending in ite is called an us, so bromous acid. All right, so moving on to bases. We have aromatase bases, okay? And these produce hydroxide ions, or the OH minus. You can see hydroxide is abbreviated as OH, right? In water. They taste bitter or chalky. And this is, they're also electrolytes because they produce the hydroxide ions in water. These are the ones that are going to feel soapy and slippery. And they turn the litmus paper blue and phenolphthalein indicator pink. Okay, so you can see these guys. I think I have a video of when I ran in the chemistry lab. I'll try to find it and show it to you in class, because I used to run the chemistry labs in my last job, so it was fun. All right, so how do we name these? Well, typically we name them hydroxides. And so you have sodium hydroxide, potassium hydroxide, barium hydroxide, aluminum hydroxide. And you can see that a lot of times these are used in more common things than what you would think. So calcium hydroxide is also called slacked lime, and this is used in the food industry to produce beverages, and in the dentist beverages. Oh my good lord, that's funny. I'm going to leave that in there. I'm not going to edit it out so you can laugh at me. Beverages, and in the dentistry as a filler for root canals. All right, so here is a little study check for you. So pause me and come back. So how do we do? So this one is going to be nitrous acid, right? Because we have the nitrous and then the acid, the H is in the front. This is calcium hydroxide. Then when the H is in the front, it's sulfuric acid, iodonic acid, and then sodium hydroxide. All right, great job, guys.